Okay, today I'm going to cover the Unit 2 exam review. I'm going to do 3 separate presentations, one for each of the chapters. So we'll start with Chapter 8 and do the first 7 problems. Okay, first question is the A equals PB, where A is the amount, P is percent, and B is the base. You can use that formula, or you can use the is over of equals percent out of 100. Okay, so every time I talk about both of them, right? So when you use the is over of equals percent out of 100, you take the word closest to is and you put it on the top of that fraction, the word closest to of, and you put it on the bottom of that fraction. And then if you happen to be given a percent, it would go over the 100. Okay, in this case, we have 3 over 60 equals x over 100. All right, so then to get the x by itself, you simply multiply both sides by 100, and the answer comes out to 5. Now, the upside to this equation is the 100. That is taking care of the changing from a number from a percent to a decimal. It does that for you so that you don't have to remember to do that step at the end. Now, I know many of you didn't learn this method in school, so a lot of you are doing the A equals PB, which is perfectly fine. And you see here that I noted 3 is the amount and 60 is the base. So I plugged in 3 for A and 60 for B. And then I divided both sides by 60 to get the P by itself. And that leaves me with 0.05, which would equal P. Now, that is a decimal. You need a percent. So remember, to change a decimal to a percent, you move your decimal point 2 places to the right. 2 places to the right. I used to always tell you about the alphabet, right? In the alphabet, the letter D is on the left if we're on a number line, and the letter P is on the right. So if I want to move from decimal to percent, I have to move from the left to the right. Okay? And then vice versa if I want to go the other way. So if you do use A equals PB, make sure you move your decimal at the end to change it to a percent. Okay? If you use is over of, the 100 in that formula takes care of that for you. Okay, so I know it's been a while. If you need more practice on this, remember it was the beginning of Chapter 8. Okay. All right, so the next one is a simple interest rate problem. And I noticed that all the values are just simply listed right below the question. Okay, the important part of the question is that it asks for the interest. Okay, that tells you want to use the I equals PRT formula. There's another formula for simple interest, but that one will give you future value, and we don't want that. They're specifically asking for interest. Okay, other things to note. I have taken time and care to change your rate from 4% to 0.04. Remember, when using any of the formulas in Chapter 8, you always want to change your percent to a decimal. Always, always, always change it to a decimal. And then I double checked that the time was in years. Remember, with all of these formulas, we want our time in years. Okay, so I went ahead and plugged all those values in. 270 times 0.04 times 2, and I was really crafty and put in all the possible parentheses you might need. And it does say round to the nearest cent or round to 2 decimal places, I'm not really sure, which means you want to get $21.60 as your answer. Okay. All right, on to number 3. This again is a simple interest problem, okay? And you can see the words simple interest in the actual question, okay? Again, they lay out all the values for you, all right? But they're a little tricky this time. The question actually says find the future value, which is the other simple interest formula, A equals P times 1 plus RT, all right? So the trick here, I did change R to a decimal, but also I had to make a conversion on the time. They said 3 months. And you need to change 3 months into years. Every time must be in years. So we can talk about 3 months. Well, that's 3 out of the 12 possible months that are in a year. So 3 over 12. Again, I went ahead, plugged all those values in, gave you all the parentheses I think you should need when typing this in your calculator. And I also believe this one says round to the nearest cent or 2 decimal places, which would be $2,035. It actually comes up even if I remember on the calculator, but the answer sheet said 0.00, so I put 0.00. I think my math lab will take it with or without the cents. I'm not wholly sure though. But the big difference between number 2 and number 3 is what they are asking for. So make sure you're using the proper formula so that you give them what they're actually asking for. Okay? Alright, number 4 was multiple parts, so I have multiple slides. Okay? There's only one number changing on each slide, and that is the time in years. Okay, so I know number 4 has a lot of words, it's super confusing looking, but just bear with me and you'll notice it's very subtle the change here. Okay, so I went ahead and did 2 columns, person A, person B, since we're doing a comparison. And then both are compound interest, okay? Both are using the future value formula, okay? So I put that formula in here. It doesn't look all that pretty, but this is how it'll look going in your calculator, so I figured that'll work. All right, now, they're in different amounts, the 2 people. So one is 2,850, and the other one's 2,400. Okay, the rate for the first person is 3%, which I changed to a decimal. And remember, N stands for the number of compounds in a year. Okay, and the first person is only 1 compound per year. Okay. Then the other person has a rate of 4%, which I changed to a decimal, 0.04. And then this person was compounding monthly, so therefore their N has to be 12. That's 12 compounds in a year because there's 12 months in a year. Okay? And for both people, the time is just 1 year at this point. So I came down here and in the formula, I plugged in all my values. So my principal, and then 1 plus my rate divided by N, which in this case is just 1, and raised it to the 1 times 1 power. Remember that your power is N times T in this formula, so you really don't need it, but it's a good habit, right? And then I got 2,936 for person A. All right, for person B, I plugged the numbers in, okay? $2,400 times 1 plus 0.04 divided by 12, because monthly compounding, raised to the 12 times 1. So again, you could have just done 12, we get it, right? So they would have $2,498, okay? And then the question actually asks for the difference, which means subtraction. Difference is always subtraction. So $438 would be the difference between person A and person B after 1 year in their accounts. Okay? All right, so I want you to pay really close attention because literally all I did between this slide and the next is change T to 5 for both people. I adjusted right here the time at the end of each line to 5, and then obviously that changed the future value. So let's switch slides. And here you see, same investment, same rate, same number of compounds, same for person B. However, now time is 5. Okay, so you see the adjustment right here at the back of the formula where time has now been changed to 5 on both. Okay. Plugged it in my calculator. Like I was saying before, I tried to put all the possible parentheses you could imagine ever possibly needing in here. So this should be exactly how you should type it in your calculator. And for person A, I got 3,304. And for person B, I got 2,930. And then my difference was 374. I'm actually vaguely remembering right now that the problem said wait till the end and round to the nearest dollar. And that's how I was coming up with all these even differences. So wait till you've found out the person's future value, round that to the nearest dollar, and then calculate your difference. I'm just now remembering that. Okay, so like I said, it should be the same formula you were putting in for part A, just changing this one number on each of them. Okay, so I mean, one suggestion I might have, if you're pretty crafty with your calculator, calculate part 1, write it down, back it up, change that one, because it's at the very end of the line. Okay, so go back up, select that line you just used and executed, bring it down and edit, back it up and change the 1 to a 5, hit enter again, write the value down, and then do the next one, which is 20 years. So select that formula again, back it up, change the 5 to a 20, write it, so that you don't have to type this in over and over and over and over again. If you're not sure what I'm talking about with the editing a previously executed line, I can show you a video on how to do that on YouTube. Okay, so yes, calculate person B as well. And then down here you see I, again, calculated the difference, $374. So less of a difference now. Person B is making a little bit closer to person A in interest. Okay, here we go. Next slide. All right, finally, after 20 years, person B is making more money than person A. So, like I said, you can see here, the only thing that's changed is the time. And so it's at the very end of the line there. You see time has changed to 20. Plug it in your calculator. You get 5,147 for part A, or person A. For person B, again, the only thing that changed is this 20 here. 5,334 for person B, and now the difference is $187 in person B's favor. Finally, they have finally made more off of their investment than person A. Okay, so like I said, I know for a fact the problem that we did that was most like this, which I actually sent you Excel spreadsheet for, was the chapter application. But I'm assuming you probably did some of these in your homework, right? But it's just the same calculation, changing one small part of it over and over again. So, all right. All right, problem number 5. Now, this problem is about compound interest. And I know it seems simple, but I did put that there's a little extra step in here because they give you the principal, $24 they bought the island for. They give you the rate, 5%, which doesn't seem like much. And then they tell you that it's compounding monthly, right? So you know you want to use our compound interest formula that we just used for number 4 over and over and over again. The trick here being the time, okay? And so they say they bought the island in 1625, okay? And then they say, blah, 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 all this stuff, and towards the end you can see they say, in the year 2005, how much would they have earned if they had compounded monthly interest? Okay, so the 2005 is the other time year that you need. It's really tricky. So you have to take the year 2005 and subtract the year 1625 when they initially bought it to find out that this money would have been sitting in an account accruing interest for 380 years. Literally, I'm not kidding, 380 years, okay? And so you see it's the same formula we were using on number 4, compound interest formula, and monthly interest, so the n is 12, and then you see it's raised to the 12 for months times 380 years. Now, the trick here, what's going to happen is many of your calculators are going to come out and you're all going to be all mad at me, okay, because your calculator is going to be in scientific notation. And it's going to say 0.41177803363 times 10 to the, I think that's 10, times 10 to the 10th power. Okay? It's not, look, don't freak out on me, okay? Just find the multiple choice answer that has the same digits you see on the calculator. Don't worry about where the dumb decimal point is, okay? Just find the multiple choice one that looks identical to what your calculator has for numbers. Forget, regard, disregard, whatever the word is, the decimal point. No one cares about the decimal point in this problem. Okay? All right, so then part B is what if the income or the principal was continuously compounded. Now remember, anytime you see the word continuous with compounds, you have to use PERT, special letter E. I know how much you guys like that. Remember, I believe you have to shift to get special letter E, and it automatically goes into the power exponent area for the R and the T. Okay, but I did write it down here, kind of the way it should look on your calculator, 24 times special letter E raised to the power of 0.05 for 380 years. And then again, remember, your decimal point is probably going to be at the start of this number, 0.42835752223. Some of you have like EE 10 or times 10 to the 10, whatever. Like I said, no one cares about that part. Find the multiple choice answer that matches the digits on your calculator. Okay, don't worry about the decimal point, just the digits. All right? So overall, same formula you were using in number 4. The time is huge number, therefore the amount of money is in the billions, right? Because it's been sitting in that account for almost 400 years. Okay? All right. Now, number 6. I think there might have been 3 parts to number 6, so I made a slide for everyone. Okay, so starting off number 6, car loan problem. So, I believe it's asking you which is going to be the better loan to get, I believe. But it asks you for all kinds of information. So, it starts out telling you that the car will be $17,000. It gives you the rate. Note that I have changed it to a decimal. N is the number of compounds in a year. We're doing monthly payments, so N should be 12. And the time is 3 years. I believe that they say they want to do 3 years. So I went ahead and I copied the payment formula off of a website so that it would be nice and clear and look like what I used to write on the board for you. Okay. I know how much you guys love this formula. So then I went ahead and started here at the 3rd dot, the payment formula. Typically what I do is I do 17,000 times parentheses 0.051 divided by 12, close my parentheses, and hit enter, or equals. That's what I do. Then I type the division sign, so now your calculator screen should read ANS division sign, okay? And then I do parentheses 1 plus, parentheses 1 minus, parentheses 0.051 divided by 12. Close it twice because I want to raise this whole section here to the negative. Don't forget negative. And you can type 36 or 12 times 3. Doesn't matter. Just make sure it's negative. Okay? Close again. And you should come out with $510.27. I believe it says round to the nearest cent or 2 decimal places. Okay, so it's a first blank it's looking for. $510.27. All right. The next blank says find the total interest. And remember, to find the total interest, what we have to do is take our monthly payments multiply by 12 months in a year, and then multiply by 3 years. This part in the parentheses will give me the total that I paid for the car. I have to then remove the cost of the car, the principal, in order to find just the interest. Okay? So if you type it in exactly how I have it here in your calculator using the parentheses, it should come out with $1,369.72. Notice that you definitely want to go ahead and use the rounded value you put in the first blank when you do this total interest calculation. Use the rounded value. Okay? All right, so that's what we got so far for the first two answers that this question requires. All right, next part. What they changed here is the rate. I mean, it's a teensy change. And then the time. Now it's 5 years instead of 3. Okay, so again, I tried to type it exactly how I would put it in the calculator. I would type the numerator, hit equals, then type the division sign so that my calculator would say ANS divided by, and then start all my parentheses for the denominator. Okay? Again, rounding to 2 decimal places or the nearest cent gives me a monthly payment of $322.37. Okay, so that should be technically the third blank on this problem. Now the total interest, again, I have to find the total amount I paid for the car and take away that principal. So go ahead and multiply by the number of months in a year, by the number of years, and that's my monthly payment, and then subtract the cost of the car, giving me a total interest of $2,342.20. Okay, I haven't said it so far, but remember, I mean, when the slide comes up and after I've explained it, you can pause, do the calculations, make sure they line up with what I've calculated, and then continue on with the presentation. So that's what's better about this than in class is you can pause me. That's funny. Okay, maybe not. Next slide, part C of number 6. Now, the question says, which one is the more economical loan option? Okay, so more economical in this situation means paying less interest overall. In other words, paying less, period, overall, because regardless, you're paying $17,000 for this car. But depending on the interest is how much on top of that you're going to pay for the car. So what I wound up writing here at the third dot is how much interest for part B was actually the most, and interest for part A was less, okay? And I went ahead and subtracted and found the difference because, as I noted here, if you don't know what they mean by economical, the hint is that they ask you for what's the difference in the interest between the two options, okay? So go ahead and calculate that, $972.48, okay? And that would be the difference. You would save $972.48 by choosing the option from part A, which is the less years, because it would be less interest, which in other words is less money overall, which makes it more economical. Okay, all right. So that ends number 6. All right, number 7, last one from chapter 8. Okay, number 7. It's another payment calculation. It's kind of I don't know, I wanted to say sneaky because we didn't do one that looked like this in class, okay? But it does say that they want to know the monthly payment for this credit card. They give you a principal. They give you a rate, which I changed to a decimal. They said it's a monthly payment, and then they said to pay it off in the next 4 years, okay? So I went ahead and did the same payment thing I was doing on all the parts from 6, okay? I wrote it out the same way. This should be how you put it in your calculator. 3,000 times parentheses, 0.18 divided by 12, close your parentheses, equal sign, and then hit division sign, I should say ANS division sign, and then start all your parentheses for the denominator, okay? Again, don't forget that this is raised to the negative 12 times 4. Always negative NT on payment, always, okay? In that power at the bottom. Okay, so it said, I believe it said round to the nearest dollar, and that was $88 is the monthly payment to pay off your $3,000 credit card bill in the next 4 years. Long time. And then the next part asks you for total interest. Same thing they were doing in number 6, okay? They want you to take the monthly payment, multiply by the number of months in a year, times the number of years, and then subtract the principal so that you get just the interest, $1,224, okay? Now, what I wanted to say, notice that you don't see mortgage loan amortization schedule. Notice that you don't see a credit card, find the average daily balance, yada, yada, yada question. What else isn't here? Well, a mortgage question. There's not even a mortgage question, it's just the car loan question. These are missing because they're very time-consuming problems, okay? They want you to complete 20 problems in 2 hours, so you're probably not going to get any of those because they just take too much time, okay? I'm not saying don't look at them. Obviously, the best thing to do is be prepared, right? So glance them over, okay, but don't get super upset, okay, if you forget to look over them because you don't see them here. You may find them on the Unit 2 exam review that's available on MyMathLab. I just don't even think they're in the question bank that I know of. So just make sure you're good with these and you know when to use what formula, and do not forget to ask for the formula book. You definitely will need that. Okay. All right, so that's Chapter 8 done. So then move on to the next video to see Chapter 10.